hello, can everyone hear me? Oh, I shocked that guy. Woke him up. Okay, my name is John Leach, and I'm from Brightbox, which is a Rails hosting company, and we do lots of things with Unix as well as with Rails. My background is kind of with both. I'm kind of a Railsy Ruby developer, partly by a hobby to begin with, and then, but my history before that was a Unix sysadmin, and I find that they're two different worlds, and there's obviously some overlap because we tend to need to run our Rails stuff on Unix stuff, or tend to do so, but we don't, as Rails developers, don't always know everything that's going on or what's available to us in the Unix world. And I know I've seen a lot of Rails developers, Ruby developers to a lesser extent, because Rails tends to be, or has been traditionally, the choice for web, for writing web applications. Reinventing stuff, things that have already been done decades before in Unix. So I thought I'd talk about a few things that are available in Unix land that have solved problems ages ago that we should probably make use of. So quick introduction, Unix people. I say Unix, some people say like Starnix to kind of mean all the kind of Unixes, but the reality is nearly everyone's deploying Rails stuff, certainly, on Linux. They're probably developing it on Apple quite a lot, which is a Unix, the BSD. I don't know if anyone's running anything on Sun. If they are, they might be in trouble now that Oracle's bought Solaris. SCO, so Linux most likely, but these are things that are actually part of the Unix and POSIX specification, so should apply. But my experience and background is Linux, so I know for sure these things work with Linux. So as we say up here, I'm going to introduce you to Unix people. Here's an example, prime example. This is Linus Torvalds, so he wrote Linux. Let's have a look. I don't know who this dude is, but he's a prime example of a Unix person. Big long beard, big glasses, big beard, scruffy top. What have we got here? I think this is Larry Wall, the guy who invented Perl. Very nice shirt. You can identify Unix people usually by the shirt. And if you've only got a face, we've got you'll be able to notice us by our teeth and facial hair usually. Let's have a look. Huge big glasses. That's another one. If you see anyone in a server room playing a flute to a butterfly, odds are it's a Unix person. So this is Richard Stallman, who's definitely a Unix person, or a GNU person, which is GNU is not Unix, but that's a whole different talk. But yeah, the long hair, beard, it's a bit of a clue there. Alan Cox from Red Hat, beard, weird hat. Rails people are a little different to Unix people. I know you're not all Rails people, but and I'm sure there's a big difference between Rails and Ruby people, but Rails people do differ quite a lot, as you can see. Great teeth, handsome guy, tanned, nice hair. I don't know how he had any time for programming with all the preening he has to do. What else have we got here? Look at this dude. Has he got to take a minute from his workout schedule to deploy a Rails app? So yeah, little hipsters. That's what it's all about, isn't it? Really, you've seen them all the place. If you've ever worked with New Bamboo, prime example of a whole bunch of very well dressed, good looking guys. This is actually a Rails developer. I forget his name, but it's from his website. It's true. So those who do not understand Unix are condemned to reinvent it poorly. That's a common quote. So you've got to understand it and know what's there. Otherwise, you're just going to end up reinventing these things that we've already solved ages ago. So what we really need is the best of both worlds. You know, we need the old school kind of Unixy person and that kind of knowledge, and we need to kind of combine it with the future Rails thing. So this is what we're aiming for. If you can't pull this off and be a one-person thing, what you need to be is imagine yourself as Tom Cruise, you know, a good-looking guy, and you want to do is find yourself a sysadmin, and he's your rain man, and he can follow you around and solve all your problems for you. But don't take him gambling. Okay, this guy's got the right idea. Beard, Rails t-shirt. I don't know which side he started on, but anyway. Okay, so scheduling tasks with cron. Okay, it's probably a good starting point since we've probably all done this. yeah, I don't know of anyone yet who's decided on deploying Rails, so they need to have a task to run on a regular basis and written themselves a cron daemon in Ruby. They tend to not already know about cron. So it's a perfect example of it. You write yourself a little cron tab config file, you set all those weird stars and numbers and shit, and then it runs on a regular basis, or every minute if you get it wrong. And then and that handles it for you. So there's a daemon running on the machine, and it's read your config file, and you've told it which script to run, and it handles it for you. You don't worry about it, it's not doing any Ruby for you. Perfect example. Or I have seen some examples now where they're pushing that stuff out of the cron stack and up into Rails, and I think that's the wrong thing. I think you should have all your tasks defined separately in your cron tab, and we should figure out ways to write cron configs as opposed to start making Rails and Ruby do it all for us. So I won't spend too much time on that, that's the obvious one. Background processing with the at daemon. Just like cron has got a cron daemon, it's cron d. There's at, which is the at daemon. And instead of regular things like you want to run with cron d, there's at d just runs things at certain times. Usually at a particular time, so you say 3 o'clock in the morning tomorrow, run this task for me. In other cases you can say, run this as soon as the system's not very busy. An example, possibly not great in production, but just an example to illustrate this. You want to convert a JPEG to a PNG, and you don't want to do it inside your action while the user's waiting. And usually you do all that job runner, background job stuff, and then you need to run monet to keep your background job running, and it's all a mess and annoying. You could just, in this case I'm echoing, but you could just write this string, which is convert is the tool that you're using to convert rows.jpg to rows.png. You pipe that string into the batch command, and the batch command sticks it in a spool directory on the local system. And the batch command sets it up so that as soon as the load drops below, I think the default's something like 0.5 or something. As soon as the load drops below a certain point, a daemon will run that program for you. And you can obviously just queue up as many of these things as you like, and as soon as your system's got a bit quieter, all these programs will get run. It is quite a simplistic example because you don't really get you don't get any feedback really about how things have run. So you might want to use it in this scenario, but sometimes you want to fire off a rake task or something, and you know it needs to get done, and you don't want to get cron's not the right thing because it's not a regular thing. So this is a good example. I think if you want to run it at a certain time, instead of piping to batch, you can pipe to the at command, and you can actually specify a time, like in 2 hours or at 3 a.m. or whatever. Logging. So in Rails, we tend to use the Ruby logger. We fire off messages to it, and it sticks timestamps in for us. And it puts it on files on disk, usually. And it's even got like a log rotation built into it. If it gets to a certain size, change it. We'll talk about that in a moment. But I've seen people saying, oh, now I've got a whole bunch of these app servers. I've got more than one. My site's scaled, and I've got venture capital. And I need to add lots of app servers. And my logging is now distributed across all this place. And I want to grep through all my logs to find problems or whatever. And I've seen some examples where people are like, I can pipe it into MySQL, which is definitely the wrong thing to be doing. And now obviously we've got key value stores, so that solves that problem. We can put it in there. No. We've got syslog for this. Nearly every single Linux has got a syslog daemon running on it already. That's how nearly all traditional Unix programs are doing logging. And instead of logging directly to files, they log to a socket. And there's a daemon listening on that, the syslog daemon. And the syslog daemon decides what to do with that. Usually write it to a file. I've got some examples here. Yeah, so in this example here, the top line's missed off, but there's a line where I do some initialization, and you say open syslog, and then I can do .debug, and it does syslog test there. I can do an info, warn, critical, bit much like the logger class. The timestamps and stuff are added by our syslog daemon, so we're not putting the timestamps in here. What's interesting though is once you've got everything going into the syslog daemon, you can then use the capabilities of your syslog daemon to ship your logs into different places. I say ship, that's probably the wrong word. In real time, you can replicate your logs any way you like. If you've got no local file system, you can your syslog daemon can just send them to a central syslog server. So a common thing would be you have a whole bunch of app servers, everything's logged into its local syslog daemon, and its local syslog daemon's relaying that to a central one, which certainly with some of the more advanced syslog daemons that are kind of becoming more established now, you can do all kinds of stuff. You can have regular expressions and say, if this thing's in the log message, put it in this file, put it in that file, or if you really want, you can insert it into MySQL at that stage, but I wouldn't recommend that either. But the point there is, it's another part of how the Unix philosophy is that it's specialization. So instead of you writing your app to do all these advanced things for logging, send it off to a log daemon, and that has all this advanced stuff in it. Other advantages are that you don't have to trust your app. So if someone, say, hacks your app, they can write anything they like to the logs. For one, the app's got access to the log, so it can write anything it likes in there or change anything in there depending on your permissions. You have to trust the timestamps, because they could have just inserted any old timestamp in there. If you log into syslog and your syslog server's elsewhere and protected from your app, someone attacks your app and gains access to that server, and they can't modify and mess with your syslogs. They can obviously create new syslogs, but they can't change the timestamp, so it's a bit of a clue there. So there's some security issues there that are useful. And it's also got rate limiting built in, even really quite old syslogs, but the modern ones have got more configurable ones. But if something goes mad and starts just filling your logs, syslog will, if they're identical log messages, syslog will spot that, and instead of logging every single one, every minute or something, will log a line saying the last line was repeated 1,000 times, and so on. So it stops someone denial of servicing and filling up all your logs and your disk space. So that's logging. Resource limiting with our limits. So we've got the common scenario now where we're moving a little bit away from it, but you have a bunch of mongrels and they're running your Rails app, and you are developing in an agile fashion, so it's got lots of memory leaks. And so the mongrels keep exploding with a huge amount of RAM usage and breaking your machine. So obvious solution to this is to run another program which takes some more RAM and have that every 30 seconds, check all your mongrels to make sure they're not doing what they shouldn't be doing, and if they are, run the stop script, which only works if mongrel's behaving, and all that kind of messing around. Obviously the problem's been solved now with Passenger because, well, it uses loads of RAM and you don't know about it because you can't stop or start it, so that's no better. But obviously that's no good. We've got Monit checking all these things every minute, see how many megs of RAM it's using. If it's checking every minute and someone, a bug in your app explodes and causes a massive amount of RAM usage, within that minute, it's of no use at all to you. But a good example here is if you anyone using laptops, if you just run this command, your machine will become completely unresponsive and you'll lose all your data. I can see that guy stop typing mid-sentence. That'll just allocate tons and tons and tons of RAM, and your machine will just become unresponsive. Everything will start going at swap. There'll be a big swap storm, and everything will fall apart. If you were monitoring that with Monit, even every 10 seconds, it would be no use, because within a couple of seconds, you've allocated a couple of gig of RAM there and broken everything. Linux has or Unix is, and Linux in particular, has the concept of resource limits. So your kernel, which is your gatekeeper between your RAM and your programs anyway, and amongst other things, the thing that you're asking, can I have some RAM please, that can decide whether you're going to get the RAM or not based on some settings that you set before you run the program. So instead of running something that's checking every 30 seconds, you tell the kernel, just basically don't let this program get any more than this amount of RAM. We've got an example here? Yeah. So if we ran that, it would cause a problem. If we limit here, what's that, 100 meg or something? I think I'm just limiting there. I'm setting, this is just a bash shell, ulimit is a command for setting our limits. Don't really know why that's the case, but so we've set it to 100 meg, we run that, and instead of allocating gigs and gigs and gigs of RAM and crashing your machine, at 100 meg, the kernel will just refuse to give it any more RAM. Obviously, it's not great. I mean, we've got a no memory error. I don't think you can catch that, or if you can, if you rescue from it, I don't know what you'd do to solve the problem, because you can't allocate any more RAM, you've run out. So it's not a great situation to be in, but it's usually a better situation than your entire machine falling apart. So usually you tend to be a bit more conservative with the settings, rather than like with Monit, where you'd say, okay, I generally use 120 meg for my Rails process. I'll set Monit to be 150. you kind of want to be looking at a worst case scenario here, so you might set it as a 200, 250 or something. It's basically something pathological. You know that you should never hit, and if you are hitting, it's because of a problem in your app. Because you don't get a nice signal in some way saying, ooh, you're using a bit too much RAM. You really just get a, sorry. So I'd suggest to be setting, you can either have your program set its own R limits, or you can just set them in before starting them. In fact, as soon as I run the ulimit command there, basically my shell has got a limit of 100 meg of RAM, so any program I run can only use 100 meg of RAM, or it'll be killed like this. So gone are the days of smashed up swaps. CPU and disk I/O priorities. So you've got say you're running your app on one machine. You've got one app server. It's got a Nginx on there, a couple of mongrels maybe. You've got a background daemon and some video encoding processes. Obviously, the video encoding stuff's not as important as your Rails app, but uses a lot of CPU. What you can do is you can have your kernel, your Unix kernel, you can give it some clues about how important things are, and it'll give CPU out accordingly. So have we got an example here? So I've got a rake task here that's going to update my Zapier database, and it's going to take 20 minutes. We always know it takes a good 20 minutes, and it's like 100% CPU for 20 minutes. And it's running on the same machine as some other things. It's not important that it finishes any quicker than anything else. This is the real-time stuff that I'd much prefer to get priority. If you run it under the nice command, so in this case I'm giving it a priority of 19, which is the highest number priority, but the lowest priority, the kernel, in essence, will give it 19 times less CPU, or less access to the CPU, at full contention. So basically if you've got a busy web app, or you've got a busy period where your web app's running, this process will just basically be sitting around waiting until everything else is finished. And you don't have to worry about going, oh, is this a busy machine? Is it a good time to run it? Should I think about running it at 3 a.m.? You can just, if you've got the RAM, fire it off, and you'll be given the CPU when it's not in use by other things. I did mention disk I/O priorities. The same works with disk I/O. Obviously, we've all written programs that aren't CPU bound. Sometimes they're disk bound. So you've got one program, again, that isn't a high priority. You don't mind if it takes 2 or 3 hours to run, or 5 days really, but it needs to get run. But it does a lot of reading and writing to the disk, and you want your real-time process that's serving users directly to have priority to reading and writing from the disk. And I/O nice does the same thing as that nice minus, but for disk I/O. So in this case, -3, it's like the most idle category. So if anything else on the system with a higher priority, a better priority, needs access to the disk, it'll jump the queue, and this will get sleeped behind. So you can chain these together. So you can stick the nice minus N19, and then the I/O nice minus C3, and then the rake task. So you've got a rake task that's going to have minimal access to your CPU, minimal access to your disk, but you know it's going to get run. And if you run it under ulimit, then it can never go crazy and crash your other things as well. So you chain all these together. Again, part of the Unix philosophy, write one thing that does one thing well, and we've got the I/O nice and the nice and the ulimits and stuff, all separate things. I'm racing through these. So obviously there's a bit, let's have a look. Atomic renames, okay. POSIX file system, POSIX is like a specification, and POSIX compliant file systems have certain behaviors. And one of them should be that renames are atomic. So when you rename a file, it either happens or it doesn't. There's no in-between state. So you'll never have one process reading a directory listing and get a program that's kind of half in the middle of getting renamed. It's either one or the other. You never get two, you never get none. You can exploit this in a few different ways. One of which is if you're a good example is you say you've got in fact, mail directories is a good example. There's you've probably seen the mailbox format for storing mail. There's another format called mail dir, and it's got 3 directories in it. Current, or CUR, new, and temp. It solves the problem of locking. It's completely lock-free. There are no locks, but you'll never be in a position where you're half reading a file that's half being delivered. So usually with the mail system, you've got an IMAP daemon or a POP daemon or whatever reading mail from your mailbox, and then you've got another program that's delivering mail into mailbox. And you can imagine that if something's getting delivered, and say it's a 100 meg email, halfway through, it's 50 meg. As it's writing this, if you read your mailbox, you'll get half a mail, which is no good. I mean, you might think, let's stick it in MySQL, it's got transactions. Again, the wrong thing to do. We can use atomic rename, so mail dir, when it's delivering a mail, so when it's in the process of writing a mail into a mail dir, it's putting it in the temp directory. And your IMAP daemon is looking in the new or current directory. Only when your mail transfer agent has finished, or mail delivery agent has finished delivering the mail or writing the mail to the temp directory, will it then move it into the new directory. So from the IMAP daemon's point of view, it's only looking in the current and the new directory the new directory for new mail and the current directory for read mail. At no point does it see half a written email. Suddenly an email appears in there when it's completely finished writing to disk. And it's the same when you click your mail and say it's read. It doesn't have to worry about having a database of which mails are read and which ones aren't. It just moves it into the the current directory, which is the read mail, basically. So we use it for our, we parse all our MySQL slow logs and put them into our control panel. So we have a whole big system that gets all these MySQL slow logs from all our MySQL servers all over the place into one directory somewhere. And then we have to work down them and parse them into a new format. And then we have another program that reads the parse thing and puts it into our control panel. So as we go down this list of basically raw logs, we're parsing them into a temporary file in a different directory, and that takes a minute or two. And then when it's ready, we move it into this other directory that another process can then start going down and start moving in. And we don't ever have to worry about making sure that our parser is finished before our importer runs. We can just run as many of them as we like, because there's no point at which a half-parsed MySQL log report is ever in that directory. It's all atomic, it's immediately there. So, you can use the same pattern for all kinds of things like that. You can do secure self-cleaning temporary files with Unix. Is that a question or a stretch? Or both? Neither. If you create a file in a Unix file, on a Unix file, POSIX compliant file system with a Unix kernel, and then open it, so you've got a file handle, and then delete the file, or as it's called, unlinking the file still exists. You've got access, you've got a file descriptor open, you can read and write to it. Anything you write to it is on disk. And for the duration of you holding that file descriptor open, you can still read from it as well. But no one else can see it in a directory entry. It's taking up space on your disk. No one can rename it or look inside it or play with it. Actually, root can do this with some clever magic, but other users can't, no matter what the permissions are. So a common thing to get a good, secure, self-cleaning temporary file is to create a random file in your temp directory, open it, and then delete it. And then you can do all your reading or writing to it, and no one can do anything with your data. And as soon as you close that file descriptor, the data's freed up, so it's self-cleaning as well. So if you've got this temporary file and you've done it this way, and then your machine crashes and you reboot it, you don't have to worry about cleaning up your temp files because it's just unallocated for you. And like I say, very secure because someone can't enumerate it and see what you're up to. You just can't use it between processes unless you can pass the file descriptor between, which I don't think you can. Anyway, page cache expiry with find. I don't know, I think it's in the core utils package in most Linuxes, so we're heading more towards like another user land here. The find command allows you to enumerate files and directories in a file system and do things with them. Either print them out to you so you can see what they are, or run programs on them, or in this case, we're going to delete them. So quite often you've got a big page cache, for Rails. You've got hundreds of little HTML files all over the place, lots of different paths, and then you change something, and you need to expire it. But you don't want to expire all of it. You just want to expire things that are over 10 minutes old, for example. Otherwise, there's going to be a massive load on your app. So rather than RMRFing the whole page cache, which is a common pattern, we're going to use find. So in this case, we're saying find all the type F means all the files in the public cache directory that are more than 10 minutes old and delete them. So, we could run this every couple of minutes or every 10 minutes, I guess. And we're expiring older page cache stuff. That's an interesting thing, actually, where that's one way of doing page caching expiry like that, but exploiting the atomic renames comes into this as well. You've got a page cache, say even you've got let's just say even 10 megabytes of HTML. 10 megabytes of HTML, lots of little files, does take a good bit of time to remove, especially on a busy file system. If it's on a shared file system, it can take even longer because of the latency of all the little reads and writes. And this becomes a problem because it's not atomic. You start expiring your page cache, so your process, the file utils rm_rf thing in Ruby, or just your rm-rf command, starts enumerating all your directories and all your files and deleting them, and then deleting the directories, and then it finds the next directory and starts deleting all those files. But obviously your site's still live, so visitors are coming in and accessing your site, and Rails is looking at the file system and finding, oh, there's no page cache for this, so I'll create one. Because of race conditions, it might go, well, I've got a directory, and then I've got no page cache, so I'll write my page cache. I don't need to create my directory because it's still there. As it starts to write the page cache file, in the meantime, your rm-rf expiry process has just deleted the directory. And the result of that is your user gets a 500 error, which is no good. So this is a race condition thing. Atomic renames allows us to instantly and atomically expire an entire tree of page cache just by renaming it. So, as we said here, we've got the public cache directory. Instead of doing all this find, delete, or rmrf or whatever, you basically just do move public cache to move to public, deleted cache or something like that. And instantly, the whole thing's from Rails's or Nginx's or whatever your front-end web server's point of view is, the whole directory just immediately and atomically disappeared. One of the other cool things about Unix is, even if at the moment you do the move, Rails is in the process of writing a page cache or reading from a new page cache, there's no error. Because once it's got the file open, as we've said with the secure delete, you can delete stuff, you can move it around, and your program doesn't have a problem with it. So your instant atomic expiration of page cache without causing any current reads or writes to be affected. It's pretty good stuff. Where were we? Right. If you've got any questions during this, you can just stick your hand up. I don't mind. So look, log rotation with log rotate. Okay, as I was saying before, the Ruby logger class has its own log rotation built in. So I think there's an option you can set when you open the log file, and you can say, I can't remember the option, but you can say maximum 100 meg, and you just busily write away to your log file. And when it gets to a certain point, Rails will create a new log file and start writing to that, leave the 100 meg one behind. So you don't end up, at the end of the week with a 10 gig log file that you haven't got enough space to compress or move or do anything with grep through or anything. Which is, it's a neat feature, but not everyone's using a logger class, and there are some other limitations and problems with it. Again, specialized. So we already have a log rotation system on nearly all Unixes, but it's already there. All the other daemons and stuff that you're running are just writing logs, usually through syslog, and then we have a log rotation. Well, it's not a daemon actually, it's a program that runs by cron once in a while. And it's got a config file, and the config says, here are all my log files, and here are all the settings and criteria you should use to decide whether to rotate them. Usually it's by size, but sometimes, usually it's by week or month, and sometimes it's by size. So an example would be, this is a config file for log rotate. So we say, all the startup log files in my log directory for my Rails app. I want to keep 5 of them. I want to rotate when they get to 100 meg. After rotating them, compress them, and then this special option which I'll mention in a moment. So here we're going to keep 5 log files, we're going to rotate to 100 megabytes, and we're going to compress everyone with a gzip, so it takes up less space. Much more manageable, we can do a lot more, it's more useful to kind of see what's going on. In our case, we tend to on the bigger sites, rotate every day and compress them, so we get like even a good 10 or 20 gig log, even a day is much more manageable rather than having a terabyte one at the end of the month or something. Usually then what you need to do is, because as we just pointed out, if you delete a file while something's got it open in, on Unix, it still exists, it still takes up space. So if we rotate this log file, we need to tell the program whose log we've rotated to open a new log file. Otherwise, they'll either keep writing to the one we've moved, or in the case of the ones that we've compressed and deleted, keep writing to an empty bucket. In fact, you might have come across this where you've got something that's using up a lot of space on your file system, and you don't know why, and there's no files of that size anywhere, but the space is being used, and you give up, try to find out what it is, and reboot, and the space is freed up. It's usually because someone's deleted a log file and not told the program you've deleted it, and it's still writing to it. So we need to do something. The usual case is you send something called a real-time signal, which I'm going to mention in a little bit. But you send a little signal to the program that's running saying, "Ooh, I rotated your log file, can you open up a new one, please?" And it usually does it. In the case of Rails, it's a little hard to do that because I don't know, you might have a pack of mongrels or something, all kinds of stuff like that. So in this case, we use something called copy truncate. So instead of actually moving the log file atomically and compressing it, we actually make a copy of it and then truncate the file to 0. There's a potential of losing a few log entries there, but it saves having to figure out how to reload your Rails app. Everything there? Oh yeah, because it's specialized, again, it's rather than the Rails logger class, which has got basically a support, I think, for just size, maybe for days and things as well. It doesn't have anything about compression. We'd have to write that or find another class to do it. So there's loads of extra features and stuff we got here. In addition, we've got log shipping built in here too. So log rotate, you can say, after the 5 days, rather than just deleting the old logs, do something with them. You can move them onto a shared file system, put them into a MySQL server maybe, if you're insane, and, or email them, all kinds of stuff. So again, it's specialized, it's specifically designed for all this stuff. It's been tested for decades. Use this stuff for log rotation. This is less Unixy and a bit more Debian or Ubuntu specific, but it's a common thing for Rails and Ruby tasks. You want to, you want to run a daemon. We'll look at a daemon first. So we want to run a program. We want to make sure only one of them runs. I think a common thing is the daemons gem, I think in Ruby, and it'll handle creating you a PID file and give you a start and stop scripts and look in a PID file for you and all that kind of stuff. That's kind of neat, but we're writing a lot of functionality there. We don't have to because in the case of a Debian Ubuntu and similar scripts for CentOS and other RPM-based ones, there's systems that will start our program for us, write a PID file for us, and give us start and stop commands that automatically look in these PID files. And again, have been already tested by thousands of other people. So we don't write a line of code, and it's already been tested by a whole bunch of dudes with beards. Let's have a look. Have I got an example here? I've got an example of this one. So you can use the same script, which is designed for starting and stopping daemons, to make sure that you don't run more than one process concurrently. So say my Zapier indexing rake file. I don't want, I start off, my site's quite small. I've got enough records in my database that it takes about 2 minutes to run. So I decide to run it every 5 minutes. And obviously the number of records in my database increases and increases and increases, and the task takes longer every time. And at some point, it starts taking 6 minutes. But I've crammed it to run every 5 minutes. So then what I get is end up with 2 of them being run concurrently. Because if there's then 2, they take longer to run. So they take 10 minutes. And then another 5 minutes comes, and we end up with 3. And then and so on and so forth. We end up with hundreds of these. And they're all running all along the same time, doing the same work, wasting loads of resources, crashing your box. If we use this start-stop daemon script, we can use a PID file, like a lock file. So a good example of it here is start-stop daemon. Like I say, it's installed on every single Ubuntu and Debian-based distro. Directory to CD into, so that's your Rails dir. And then some magical options here that I figured out from the man page. I can't remember what they're for. PID file, so in this case it would normally be, is it /temp/pids is a commonplace for Rails. And then I'm telling it to start, and I'm telling it to start this command, rake Zapier update. And it'll run rake Zapier update. It'll note the PID file in that PID. The next time it runs, it looks for that PID file. If it finds a PID file with a PID in it, I say PID, sorry, the process ID, it can read that, and then it can look that up in the process table and see if that task's running. If it is running, then it'll just exit. So from your cron tab's point of view, it ran the task as it was supposed to do, our start-stop daemon found out that it was already running from last time. It doesn't do anything. When rake Zapier update finishes, the PID file does stick around, but the start-stop daemon, next time it runs, finds a PID file, finds a process ID from it, looks in the process table, finds that it isn't running, so starts a new one. So just make sure you don't get multiple ones of those going on. Another stretch or a question? Both? Neither? None. Real-time signals. You've got a process running, and you want to communicate with it somehow. Usually, there's a few things you want to communicate with it. And for example, like an example of the syslogs, you want to say, reload your log, reopen your log files or something like that. So it's not a complex bit of communication, just usually a little nudge or a hint, like, shutdown's a usual one. You've probably used kill minus, the kill command minus term or minus 9 in extreme cases to kill a program. That's sending what's called a real-time signal. -9 is the real-time signal for sigil or something, which means you bust stop. And I think minus term is a nudge to say shut down. Hup is one that's used for reload your config file or reload your reopen your log files and stuff. You can trap these in Ruby. So you just say trap user1 or hup or term, whichever one you want. The user1 is there's a couple of signals you can that are user customizable, and user1 is one of them. We give it a block. So when our task that's building our Zapier index library finishes, we want to tell our app to reopen the Zapier database. So we set this up inside our app, and then when our rake task finishes building the Zapier database, it can send a user1 signal to your Rails process or whatever, which will then, that block will get executed, and then it'll reopen your Zapier. So like I say, usually it's log rotation or config reload is another one. I think MERB handles, I don't know what Rails does. I think MERB handles the reload, reloads its configs and rotates its log files. Pretty certain. Yeah. No, it's not a random string. He was asking if the signal name here is arbitrary, but it's not. There's some preset ones. If you look up one of the many quality man pages, which I can't remember the name of, there's a man page that documents what these are. It might be just man signals, I'm not sure. There's a few of them. Sorry? Man kill. Actually, man kill should, if it doesn't tell you what they are, at the bottom it'll say see also, and it'll tell you where to find them. Like I say, term, sigil, user1, user2, hup, these are all predefined ones, and you have to use one of those. There's quite a few of them. Some you can't override. You can't, -9 or sigil is one you can't handle. It's one that's sent to you and the kernel will just kill you. You can't just catch it and go, no, I'd like to keep running, thanks. You get killed. But I think when you do Control-C, I think that's on something, not a demonized process. I think Control-C tends to send I think it's a term signal. So you could handle catching that and decide not to quit or to shut down and clean things up properly. How much time have I got? About 10 minutes, maybe. So yeah, they're arbitrary. There's a limited number of them. But there's usually, because it's quite, you can't communicate that much. There's not that much you would actually use it for. There's just a few preset things. You got a question? You're free to use the USR ones, yeah, okay. I think. Sorry? Can you stick any number on the end of USR? No, I think there's 2 of those. Again, if you look at the man page, it's weird, arbitrary Unix magical incantations from many years ago. It's binary, isn't it? 1 and 2. Anyway, reliable messaging with SMTP. Everyone's using Rabbit to communicate with all their programs. But mail is a good way of communicating with people. But obviously people use programs. So in reality, you're actually communicating with programs already. Why not use it just to communicate with programs, cut the people right out of the equation? It's more likely your mail will get read. In fact, most of my mail is read by a spam checker anyway. So we use it on our log shipping for our MySQL slow log parser that I just mentioned earlier. We use the log rotation log shipping thing built in. So we do a log rotation of the slow log, I think it's once a day, and the log rotate daemon will handle doing the log, compressing the log, and then sending it to an email address for us, because that's one of the features that it does. And on the end of that, we have a server which receives this email, and puts it into a mail directory, like I mentioned earlier, nice and atomically. And then we have something else that iterates over those, and each message is a mail log, and we can that's the bit that we pre-parse and decide to put it into another directory, which is then put into the database. It's great. If implemented properly, it's a reliable delivery protocol. An SMTP server should never tell you or your client piece of software that it has a mail until it's written it to disk and f-synced it to disk. So you should never lose an email, and you should never get duplicate emails. It's not always the case, so it's not the kind of thing you want to use for financial transactions, but it's handy for a few things. And in this case as well, most Unixes have an SMTP daemon running on your local machine anyway, so rather than running a job runner or something to then handle sending a message to your rabbit daemon or whatever else, you just send it to the sendmail command, which will pipe it to your daemon. In fact, I think most sendmail commands, if your daemon's not running, it'll handle spooling it to disk for when you finally do get around to running your daemon. So you've got a message, and your Rails app needs to hand it off to someone as reliably as possible. SMTP is a really, really good one. And then your app server will spend its time trying to send the email, and if the thing that is receiving is down, it'll just wait and try again later. So as long as you don't need it within an exact time frame, it's really great in that case. You've also got load balancing built in because of DNS and MX records. If you're sending to an address, you can set multiple records in your DNS to define all your mail servers. So, and we actually use this in this case. We have multiple servers that are doing this log parsing, and they're all defined in the MX records. We just send to an address, and our mail delivery agent handles looking up the DNS, and it's immediately given a list of all the servers that it could possibly send the mail to, chooses one at random. If it happens to be down, it sends it to the next one. If that one's down, it just puts it in its queue and tries again later. It's a really, really handy way of doing this. Getting answers back is a bit of a problem, but you'd have to have the whole thing in reverse, but you've already got these mail daemons running anyway. And running a program at the other end is just usually dead easy, because in fact nearly all your mail being delivered is already being, it gets to your mail program, which then is piping it into a command anyway for delivery. You could just be piping that into a rake task, and your rake task just takes a mail as on standard in. It doesn't have to know anything about SMTP or POP or anything like that. No POP daemon or IMAP, no passwords or anything like that. If you want to do it secure, you either keep it private or you use the GPG commands to encrypt and sign things. Neat. How much more time do I have? Another hour. Nice. Sorry? Oh, cool. Keep you until the last person's left. What have we got? No, actually, I won't go through too many of these. These are all the crazy ones I put at the end, depending on how quickly I roast through the other ones. So I'm less committed to these ones. Dbus is actually quite a modern thing, but it is a Unixy thing. It's basically a messaging system for a computer as opposed to a network, like something like AMQP. That's a protocol, but you know what I mean. So the idea is you have this a bus, a dbus daemon running on your local computer, and any daemons can communicate to each other using this this bus. I think it advertises a service name, and other programs running on there can send messages to the service name and they can find each other. So I don't know, maybe you'd have a number of video encoders or something, and you'd have one master process that can communicate with them all using this dbus. It's a bit wacky, but it's in most. It's mostly used for the moment for desktop use when you've got like a network manager program that needs to tell your messenger that your network's been cut off and that kind of stuff. Avahi is again a daemon for handling things called the Bonjour protocol in Apple. So again, say you want to find, you've got these video encoding apps, app servers, and you spawn different ones up depending how busy you are. You could use Bonjour or the Avahi daemon to manage knowing about all those. So you have one running all the time, and it's using Avahi to kind of tell your front-end servers, yeah, there's a video encoder server, it's called this. And then when you're busy, you can spark up 5 or 6 of them, and it will be advertising with this Bonjour protocol. Yeah, so that's kind of a good way of, like I say, self-organizing. You don't have a central point of failure that they're all registering to or anything. They all kind of find each other. I think you'd have to write your programs a bit carefully to, make sure you, again, like with SMTP, that if you were told about a box that's now gone, to make sure you send it to the next one and stuff. But anyway, modularized config files. It's a good way to engineer your own programs, is to, rather than read one big massive config file, which then a sysadmin has to, if they want to add anything to it, has to parse it and make sure it puts it in the right place, or cat it on the end, or all that kind of stuff. If your program can handle reading from multiple config files, preferably with a file pattern defined somewhere, then a sysadmin can just drop little snippets of config files into a certain directory for you. And a lot of Debian and, well, in fact, nearly all Unix packaging uses this a lot. So for example, syslog does it. We have the syslog daemon. The syslog daemon package doesn't have to know about every possible app you might ever install on your machine. It just has a base config that says, look in this directory for any other configs. And when you install your cron daemon, it writes a log rotate config into that modularized config directory. As an example, you might have your Rails app write a Rails hyphen, whatever your app name is, into the cron directory. So rather than editing your user's cron tab like you normally do, your however you're deploying your Rails app, you should drop a config into the cron.d directory. That's the usual place for it. And that's just a snippet of cron. In fact, it'll be just a bit of a cron tab. And cron will read everything inside that cron.d directory every time it wants to look at its config file. And the same with log rotate d. You can put this is how our gem actually works. When you do a deploy, it'll write a log rotate config for you, so the log rotates happen. Yes, so just have to remember to remove them when you remove your app. Probably a quick one here. So even with all your R limits and your nice and your IO nice and everything else, something goes wrong and your machine's ground to a halt. But it hasn't crashed, so it hasn't rebooted. But you can't SSH into it because it just hangs. It's a bit annoying. You have to go, if you've got a cloud thing, you go in and click reboot, or otherwise you ring someone up and get them to pull a power cable. If you're running a watchdog daemon, it's a convenient little way of just basically saying, there's a little daemon that just speaks to the kernel and says, every configurable build period says, I'm alive, I'm alive, I'm alive. If it doesn't say alive after a pre-configured time, the kernel reboots the machine, quite harshly, but it reboots the machine. So that's like your last course of action. You've got a watchdog daemon, maybe every couple of minutes it checks in and says, I'm still alive. And then when your server's really, really, really buggered, your watchdog daemon doesn't get any CPU given to it, the kernel doesn't get an I'm alive message, and then it reboots itself. And then the whole cycle can start again. So the summary being, think system-wide. Don't always think in these little Rails or Ruby bubbles where you bring all your libraries with you and everything together and all your log rotation scripts and everything. Consider all the services that are available to you on your Unix system that can provide some of these services for you. It's a little bit trickier because you have to be root to write to a lot of these config places, but with things like Chef and Puppet nowadays, you tend to be already in a position where you can manage the whole machine. So start thinking a little bit outside the home directory, basically. I think that's me. Any questions? Oh, he's got a microphone.
Hi, I just managed to kill my computer.
Yeah.
I ran the Ruby script.
Yeah.
I needed to do 1024 to the power 4 before it killed it. But I couldn't actually get the ulimit thing to stop it based on the memory usage. So I could on the time, so if I specified -t and said like 10 seconds, it would kill it off, but the -v I couldn't get to work at all.
Right. There's, I have had a report that there's some of the options don't work in OS X.
Okay.
But memory's a really tricky thing. I was going to write a slide on it, and I didn't have time. But it's a really complicated thing, because when your program allocates RAM, your operating system kind of lies to you. It says, yeah, okay, even though that might not be available. So sometimes you get given RAM that unless you use, actually write to, it isn't actually in use. And that's how the copy on write stuff works with Passenger and Unicorn to save your RAM. So it's actually sometimes really, really difficult to know exactly how much RAM a program's actually using, especially as if two programs are using the same library. A good, modern Unix will not allocate the library twice, it'll allocate it once and link everything to one place. So it's kind of difficult. But you're running 10 of these, so you're sharing it. You could say my program uses hardly any RAM because this library is loaded for this other program. But you close that program and now it's your RAM. So sometimes it's a little tricky to say exactly how much RAM you're using. And I think the example I used, was I can't remember, I think it's complete size. It's including any swap and libraries. It has to be big enough to, your library is counted as RAM against you. But yeah, check the man page and play with it a bit. Definitely works under Linux though, for sure. And I'm sure you're not running an OS X deployment server, are you? Or MySQL, no. Any other questions? Oh. Did I? Oh, I'm really sorry. I thought, I hoped it came across as a loving representation of how weird all these people look. I see myself as one of these people, and I come to the Rails world and thought, oh, I don't go to these parties. We don't even have parties. We have parties over IRC, and Rails people have real parties. I'm sorry, I didn't mean any offense to either side. In fact, I do a similar talk for Unix people from the Rails side and go, oh, these are all the cool things that Ruby and Rails people are doing. Things like Capistrano and stuff like that, that are actually really quite interesting technologies that the Unix people don't know about. It's kind of new, cool kid stuff. Sorry. I'll buy you a beer. I better not get you in a beer then, it's depressive. Any other questions? No. Thank you for listening then.